Hey, my name is Nick Rees, and recently I've been very excited to be looking into the intersection of material science with interplanetary habitation. Within the next decade, there are plans to travel and land on Mars, but to truly become an interplanetary species, we need plans to actually live on Mars. Due to a number of factors, including a lack of atmosphere, no access to liquid water, freezing cold temperatures, and harmful radiation, Mars is just a very challenging place to set up habitation. Sure, we could just live in pods and capsules, but that doesn't truly embrace the spirit of living on a different planet. And so one idea would be to live in habitation greenhouses that allow climate and atmospheric control so that humans and plants alike could live. Greenhouses work on Earth because glass is able to effectively trap the heat radiated by the sun, especially because the difference in temperatures in and outside the greenhouse aren't too extreme. However, this just isn't the case on Mars. Because the temperatures need to increase so much in order to get above freezing, the temperatures in and outside the greenhouse would be so large that glass just isn't a good enough thermal insulator to keep the heat in. One of the most promising solutions is a nanomaterial called Aerogel, which is the lightest solid ever created and is 99.8% air by volume. Aerogel is made by taking an alcohol-based gel similar to Jello, which is really just a solid structure filled with liquid, and replacing the liquid with air. What remains is this nanostructure of solid and a complex network of micropores filled with air. And these micropores is where the insulation properties come from. When air molecules are heated up, they become very excited and move really quickly. And so they aren't actually able to navigate the complex network of micropores. Similarly, it's like trying to get through a very complex maze. And so if an air particle can't get to the other side, then heat doesn't transfer through the aerogel. As a result, we call aerogel a superinsulator because of just how well it insulates for its thickness and lightweight. Because of its incredible properties of heat insulation and lightweight, aerogel has the potential to change the world as we know it and could be incorporated in numerous industries to be a disruptor. For example, one industry would be airplanes, where aerogel's lightweight paired with its sound and heat insulation properties would create a better quality airplane while also decrease costs enormously for airlines on fuel costs. Similarly, aerogel could be a disruptor in the window industry because light is able to pass through while also being 12 times more efficient than the leading standard of energy efficient windows. And this could actually cut down on energy consumption by 15% in buildings, which is incredible and world-changing. And while aerogel does sound very promising, like many new technologies, it does come with a huge cost. However, recent innovations have actually taken enormous steps forward to decrease costs and increase scale of aerogel. Where these costs come from is the process of replacing the liquid with gas to fill the aerogel. Intuitively, one might say that you should evaporate the liquid to then kind of liberate the pores and have gas. But what this actually does is it creates what's called capillary action and causes the liquid in the bottom or in the center of the gel to move up and cause the structure to collapse. And so there needs to be another way to replace the liquid with the gas. Instead, what has to happen is the alcohol in the pores has to be replaced with liquid carbon dioxide and is heated and pressurized to what's called the critical point, in which the liquid has both properties of liquid and gas, so that could then be cooled and fill the properties of then gas. And this is a very expensive process because it has to happen in the conditions of similar to a pressure cooker, which is very energy intensive and also can only happen in very small scales. New innovations are taking huge steps forward to creating aerogel in ambient conditions, so room temperature and atmospheric pressure. So we can create aerogel in bigger scales and also demand less energy. Scaling up aerogel for Mars purposes is not only going to help us leverage the greenhouse effect for synthetic habitation pods, but also allow us to actually expedite the process of terraforming Mars. One example would be to use aerogel sheets over top of areas that are either ice caps or where there's ice very low below the ground, so we can actually begin to melt this ice and liberate water as well as gas that is trapped below the surface. The liberation of trapped gases is going to help enormously in creating an atmosphere on Mars so that the greenhouse effect can be leveraged on a planetary scale rather than just on a small scale of an aerogel facility. As well, by liberating water, water is going to be that enabler of life on Mars and is also influential in creating a terraformed and habitable planet, sooner than it normally would have taken. So it's incredible to think that with a material that's 99.8% air, we have the potential to change the world as we know it and also push the frontiers of mankind to live on different planets. Thank you.